Welcome everybody, my name is Tim Sandy and I'm a VMware Technical Partner Manager and Systems Engineer. This session is the third and final video in the three-part technical series providing an overview of what's new in vSphere 6.5. If you haven't watched part 1 or 2 yet in the series, I do recommend that you go back and watch part 1 and 2 first. So let's get started with part 3. So the third area of improvement with vSphere 6.5 that we're talking about in this particular session is Universal App Platform. vSphere 6.5 provides the scale, performance, and availability to meet the demands of any application for your data center, to include supporting containerized workloads that is popular for application developers, as well as provide application automation. In regards to vSphere High Availability, or HA, we've simplified the configuration for it. As you see, you now have a very simplified workflow for configuring HA. There's not as many settings and configurations that have to be done like there used to be with 6.0 Update 2 and previous versions. You simply select the number of failures to tolerate based on percentage of resources reserved, automatic calculations, and number of overrides possible. Then it does the rest to include providing warnings if performance degradation could result with those settings. The VM restart priority determines the relative order in which virtual machines are allocated resources after a host failure. Such virtual machines are assigned to hosts with unreserved capacity, with the highest priority virtual machines placed first and continue to those with lower priority until all virtual machines have been placed or no more cluster capacity is available to meet the reservations or memory overhead of the virtual machines. A host then restarts the virtual machines assigned to it in a priority order. If there are insufficient resources, vSphere HA waits for more unreserved capacity to become available, for example, due to a host coming back online, and then retries the placement of these virtual machines. To reduce the chance of this situation occurring, configure vSphere HA mission control to reserve more resources for failures. A mission control allows you to control the amount of cluster capacity that is reserved by virtual machines, which is unavailable to meet the reservation and memory overhead of other virtual machines if there's a failure. We've also included a orchestrated restart order for HA. This will be beneficial for VM to VM dependency chains. A good example of this would be with a, say, a 3-tier web application that requires a certain start order. So for an example, in a 3-tier web app, the database server needs to come up first. And then once the database is up and running, the application server needs to come up. Once the application is up, then the web server comes up. So there's a specific start order with that. So with this orchestrated restart order for HA, there's also a validation check to detect circular dependency rules as well. And this is for within and outside priority groups. With the proactive HA, participating vendors such as Dell, HP, and Cisco have their hardware monitoring solutions that detect hardware conditions for their servers. HA can now receive notifications of impacted hosts and then partially vMotion VMs from degraded hosts to accommodate the depreciated host and keep your cluster properly balanced. So an example of this, if you're running, say, some Dell servers and you have Dell OpenManage on them, Dell OpenManage detects that, say, 1 or 2 of your RAM cards have gone bad. So it's in a degraded state. There's not as much physical RAM on this host anymore. So Dell OpenManage picks up the failure of the memory cards, and then vSphere HA detects this as well, and it'll partially vMotion VMs off of that host to where it gets that host down to a good level and it balances out between all of your hosts. The new quarantine mode is a new vSphere host state. Within a health-aware cluster, any degraded host will be placed in quarantine mode automatically. vSphere Distributed Resource Scheduler, or DRS, will evacuate VMs if there are no performance impacts, and none if the business rules are degraded. We've also updated the Distributed Resource Scheduler, or DRS Policies, which offer a simpler configuration with 3 options. The first is for even distribution, providing improved availability by avoiding too many VMs on a single host. The second is consumed memory is active, which is the default setting where DRS uses active memory plus 25% for load balancing. It also has the policy active selection, which changes the DRS advance % idle VM in demand to equal 100. The third option is CPU overcommitment. This prevents any single host from becoming overcommitted on CPU, which is great for VDI environments especially. Also, something new to the Distributed Resource Scheduler, DRS, is that it's now network aware. It considers the network bandwidth by calculating host network saturation. It helps you avoid oversubscribing a host network links. This will ensure that you don't end up with a server VMs requiring excessive bandwidth to reside all on the same host. Instead, it will keep the VMs distributed across the host to even out the network load on the host in the cluster. So again, this ensures that you don't have several VMs sitting on a single host that are your most network intensive and require the most network bandwidth out of your entire environment. This will make sure that they are sitting on different hosts and will balance kind of that network bandwidth and load across your cluster amongst your hosts. Virtual VMs now has a new architecture as well, which allows you to do bidirectional out-of-band communication with your VASA. Keep in mind that each VASA provider is specific to each vendor. It allows you to control automation through policies and offers a protocol endpoint, or PE, which directs I/O from the VM to the virtual volume. So some quick updates on storage I/O control and storage policy-based management, or SPBM. As you see here, it's managed using a policy via the Storage Policy-Based Management, or SPBM, and storage I/O limits are enforced using I/O filters, or the VI/I/O. So you can see here where you can set your I/O limits and your reservations and shares, and you can add several rules to this. VMware is working with our broad range of storage partners to introduce support for vVolumes replication. Unlike legacy array-based replication that required explicit placement on specific data stores to ensure a VM was replicated, vVol replication provides fine-grained control over VM replication. So how it works is vendor-specific replication capabilities are advertised up to the vSphere via VASA. The virtual infrastructure administrators create VM storage policy containing replication capabilities from the storage system. When VMs are being provisioned by the user, it selects a policy containing the replication capabilities, chooses a compatible data store, chooses a replication group in which to place the VM to support multi-VM consistency, and then completes the provisioning. The replication group that the user selects allows them to place multiple VMs intentionally in the same consistency group. The replication groups are advertised by the VASA provider. The storage system can also advertise a special automatic replication group that will place the VM into an empty replication group by itself to support per VM replication. For failover, testing, etc., SPBM will provide public APIs for triggering these DR operations. There will also be a power CLI commandlet provided for administrator level orchestration as well. As vendors provide additional data services via the VAOI and vVol integrations with vSphere, we're extending SPBM to better manage multiple data services. One of the mechanisms that is being introduced is the storage policy component. These components allow customers to capture service-specific configuration and a reusable policy component. For example, a customer could define a replication component and then reuse that component in multiple policies. Storage policy components are included by reference in a storage policy. This means that edits to the component can be instantly reflected in the storage policy referencing the components. So that completes the third video in the three-part series providing a technical overview of what's new in vSphere 6.5. If you didn't watch the previous parts of this series, again, be sure to go back and watch the other parts as well. Best to do them in order if possible. So hopefully this three-part series was informative for you and gave you a good summary of some of the new feature sets and capabilities within vSphere and vCenter 6.5. I look forward to having you on my enablement sessions again. Thank you and have a wonderful day.